Hi, welcome to another edition of Numero Studio. In this video, we will talk about the measures of central tendency for group data. In a previous video, we transformed the raw data on the left to the group data on the right. Now, let's find the measures of central tendency when the data is presented as a frequency table. First, the mean of group data. The mean of group data is computed by the formula x bar equals summation of fx over n. The formula suggests that we need an x column, multiply what's on the f and x columns to produce an fx column, then we'll add. But what is x? X is called the class mark. It is the midpoint of the classes, and we get that by adding the lower and the upper limits and dividing the sum by 2. So in this case, 58 plus 66 is 124, divide by 2 is 62. 67 plus 75 is 142, divide by 2 is 71. 76 plus 84 is 160, and divide by 2 is 80. And we repeat the process for the rest of the classes. Now for the fx column, we begin by multiplying 3 and 62. We get 186. 4 times 71 is 284. 1 times 80 is 80. And we repeat the same process to the rest of the classes. Now if we get the sum of the last column, we get 3,333. This is the summation of fx. Now where do we get n? We get that by adding all the frequencies, and we know that that is equal to 33. Now we plug in these values to the formula and we get 101. So therefore, the mean birth weight of the 33 consecutive deliveries is 101 ounces. Next, the median. To find the median of a group data, we use the formula at the right. It can be a little intimidating, but once we examine its elements, we will discover that it's quite simple after all. We start by looking for the median class. We do that by making a less than cumulative frequency column, beginning with the frequency of the lowest class, which is 3. We add the frequency of the next class, which is 4, to get 7. 7 added by the frequency of the next class, which is 1, is 8. And we repeat the same process until the last class. The last number should match the value of n. Now what do these numbers in the less than CF column mean? 7, for example, means that there are 7 data points from 58 to 75. 20, for example, means that there are 20 data points from 58 to 111, and so on. So to find the median class, we go back to the definition of a median. It is the value that divides the distribution into 2 equal parts. So if there are 33 data points in the distribution, half of it, or n over 2, is 16.5, which means that we are looking for a number in between the 16th and the 17th class. Now, is it in this class? The answer is no, since we only have the lowest 3 data points in here. Nor can it be found in this class, since we only have 7 data points so far. If we continue this process, this is the class where the 16th and the 17th data points are located. Hence, we have found the median class. Now the LB sub ME in the formula is the lower boundary of the median class. The lower boundary is found by subtracting 0.5 from the lower limits. So the lower boundaries of the classes are 57.5, 66.5, 75.5, and so on. Therefore, the lower boundary of the median class is 93.5. Now n over 2 is really just half of the sample size, and we know that to be 16.5. The less than CF is the less than cumulative frequency of the class below the median class. And because the classes are arranged in ascending order, this is the class below the median class. And its less than cumulative frequency is 12. F sub ME is the frequency of the median class, which in this case is 5. And of course, the I is the class interval, and we know that to be equal to 9. At this point, we all have the values needed, and when plugged into the formula, we get 101.6. Notice that this is a value that is between 94 and 102, which is our median class. Therefore, the median birth weight of the 33 consecutive deliveries is 101.6 ounces. Now, two things to remember in computing for the median of a group data. First, you always begin with n over 2, as this will lead you to all of the other values. And second, be mindful of how the classes are arranged. When arranged in descending order, just like the one on the right, the less than CF column is constructed from the bottom going up, which should always end with a value equal to n. And we are down to the last measure of center, the mode. The formula in finding the mode of group data is shown at the right, and the key to finding it is beginning with the modal class. 112 to 120 is the class with the highest frequency, and so we can expect to find the mode in this class. The LB sub MO in the formula is the lower boundary of the modal class. Do you remember how to find the lower boundary? And if you say that it is 111.5, then you got it right. Now the delta 1. Delta 1 is the highest frequency minus the frequency below the modal class. And again, because the classes are arranged in ascending order, 103 to 111 is a class below the modal class, and its frequency is 3. Therefore, delta 1 is equal to 6 minus 3, which is 3. For delta 2, it is computed as the highest frequency minus the frequency above the modal class, and the class above the modal class is 121 to 129, whose frequency is 3. And so, delta 2 is 6 minus 3, which is equal to 3. And I is still the class interval, which is equal to 9. At this point, we have all the values required, and when we plug them into the formula, we get 116. Notice that this is between 112 to 120, as expected. Therefore, the modal birth weight of the 33 consecutive deliveries is 116 ounces. As a reminder in finding the mode, the order of classes matters, and you can use this as a guide in locating your delta 1 and delta 2. To summarize, the formulas for the measures of central tendency are given, and using the frequency table on the left, the mean is equal to 101, the median is 101.6, and the mode is 116. Congratulations for making it this far. Make sure to subscribe and get notified for more videos. I'll see you in the next one.